All right. Okay, so welcome back to Chariot Tech Chat Tuesdays. This is number 63 for Tuesday, June 20th, 2023. I'm Ken Rimple.
Sujan Kapadia.
And today
I'm sorry.
I'm sorry. we always do this. And our guest today is Avdi Grimm, founder of Graceful.Dev. So I have a little blurb here on you. Let's see if we can use this as a good intro. So Avdi Grimm is a professional developer with experience across a wide range of platforms, embedded systems to enterprise applications. He's a Ruby hero for service to the Ruby community, a consulting pair programmer, writes about coding practices at Graceful.Dev, and also hosts a set of what you call audio thoughts. Is that basically as a podcast, right? The Cash Flush.
Oh yeah. My occasional podcast.
Yeah, we have the same thing. Every once in a while, it's hard to keep a podcast stream going constantly. But so the Cash Flush, I noticed that on your website at Avdi.codes as well. Spoken at many conferences, including twice at least at ETE. And it's a pleasure to welcome him to the podcast today. So let me start off just with a real simple, basic thing. Let's start with your background. When did you first get started programming? Because I'm curious, like what led you in?
Yeah. What led me in? Okay, so programming was kind of a little bit in the air for me growing up. My dad was an engineer, kind of at the cusp of hardware and software engineering, and while he didn't teach me to program, but it was definitely, it's one of those things where what you see around you is what you feel is like possible and doable as a person. And so it was kind of relatively easy, I think, for me to fall into that. That was a kind of a privilege that I had. And also he did wind up introducing me to my first full-time software job back in 98, I think it was. Which was working for a big defense contractor, mostly working on like air traffic control systems and networking middleware and embedded stuff and things of that nature.
Yeah, that in the air thing, I know it's like I do podcasts because my father was in radio.
Mm-hmm.
So I was always around, recording engineers and studios and stuff. So I've always been into that kind of thing. So I get that. So what was the first computer you programmed, out of curiosity? Was it a basic interpreter on something, or?
Oh my gosh. I mean, at some point, I know that at some point as a kid, I probably punched some BASIC out of a magazine into like an IBM XT or something along those lines.
Yeah.
At some point later, I had like a 386 that my dad got me. And I think I taught myself Rex on there because for some reason we were running OS2 because we couldn't be like normal people who had DOS and Windows. And so I don't know, I taught myself Rex, which I remember exactly none of at this point. Nobody else has ever heard of it.
I have, because it was on the Amiga.
Okay.
So I was a big Amiga geek at the time, and they brought Rex out. I paid 10 minutes of attention to it because I'm like, I don't know what I'm gonna do with this thing.
Nice.
But yeah, Rex was one of the things they ported from IBM. I'm like, interesting choice. So, well, that's cool. So all right. So we have you here, obviously, not to talk about the old days, and I know we set you up that way, but more to talk about some of the topics you brought up at the great talk you did with Jessica Kerr at Philly Emerging Technologies for the Enterprise on feedback loops. So let's talk a little bit about that. So why don't we just talk at the highest level? You really enjoy programming in languages where you can kind of ask it questions through a REPL, right?
Yes, and I think, and I'm fairly confident that I'm not the only one who enjoys this. So one of the things that I talk about in this talk about REPLs all the way up is a little bit of the history of programming, where we went in a fairly short period. We went from your feedback loop was you punch a program into a stack of cards, and then you get on a train and you go to Cambridge or something, and you wait your turn to run it through a computer, and then it says, oop, bug. And so you spend, you go home on the train and you're looking through your cards trying to figure out how you're going to adjust your program for 2 weeks from now when you get to try it again. In fairly short order, we went from that to, what was it, like late 60s, maybe even early. We had a PDP-1 running Lisp where, you could punch in some Lisp code onto that typewriter, literally a typewriter, but it would take over as soon as you finished writing that first line of Lisp. It would take over and it would type out the result of that right to you. And then later on, we got into these wonderful distributed, these mainframe systems that you could come, you could teletype into from all over the country and get like results of your basic program in like a second. And and these were incredibly, like, we've lost a lot of this history at this point. A lot of people, these days feels like computing started with the personal computer or with the internet. But we've kind of lost this prehistory of incredibly interactive, rich, and social digital citizenry that occurred, that was happening with these amazing mainframe systems. And in many ways, there was almost like I almost came into computing in kind of a dark age, or like an ice age that happened after this, when now it's like you're just on your own machine here, and you're compiling and you're waiting for compiles, and you have these slow feedback loops. So in many ways, part of my thesis is that we've recognized since almost the beginning of computing how satisfying it is to have a feedback loop that matches the pace of your questions and your next thought. And we keep trying to get back to that state of grace. And periodically, I think we kind of get close to it again.
For sure. Good.
This is a topic like so near and dear to my heart. Just at a fundamental level, I mean, feedback loops are how we interact and react to the world, right? It's like a high level abstraction that models the universe. So how we perceive reality, how we learn effectively, it's really all governed by feedback loops. So I get surprised that it's not a fundamental underpinning of an engineering or a computer science education. Like, it's not really, and I go back to how I learned it and how I was taught it, and it's not something that was ever brought up as a first class concept. And I think that is at the detriment of folks wanting to get into this field and learn it.
Yeah, absolutely. And honestly, that was the genesis of this talk. Like you mentioned, I run a site called Graceful.Dev, where I have many courses for developers who want to kind of level up their practice. And what I kind of came up with as the genesis of this talk was asking myself the question: what is sort of the overarching theme? What does it mean to be a graceful developer? What is the sort of backbone that I want to tie all of this specific concrete knowledge into? And really, what it comes down to for me, being graceful as a developer, is about participating in these feedback loops, and about honing your feedback loops, and also about seeing yourself as situated in a set of sort of concentric feedback loops, all the way from a line of code at a REPL, all the way up to the major business pivots that you're part of and that you're supporting. And these are all feedback loops. They all happen at different levels, at different scopes, at different paces. But that's all we're doing, and seeing yourself in those loops all the way up, I think, is a really powerful way of contextualizing yourself as a developer.
Yeah. I have to, as an aside, every time I hear the name Graceful.Dev for your company, my brain keeps inserting Grateful Dead. It's an awesome name. I just love it.
Thanks. Yeah, I've had a few people say that. Honestly, it was not at all on my mind when I did that. I just have a personal fascination with the concept of grace, but yes, that's definitely, people have pointed it out to me since then.
It's funny. It feels like it feels like cheating almost when you first learn how to work with a REPL and how to communicate and think as fast, get the answers as fast as you can think through them.
Yeah.
I remember many years ago, and I'll step out of the way on this, but many years ago, early on in my Java engineering, I learned about like scripting and bean shell. So I was able to like create a little thing in a servlet to let me run scripts against the servlet container. And I could interrogate everything and try stuff, and everything out of that fell into like things I could write as tests and all that kind of stuff. So but it felt like cheating. Like you said, it wasn't taught in school. It wasn't a concept, but I mean, it had been there since the 50s with Lisp.
Yeah.
And Forth and programming languages like that. It's just kind of shocking that like it really wasn't enforced, because it was almost like a toy concept to computer scientists at the time.
Yeah, but it actually turns out to be, like you say, it's a very early innovation, and I think we've been kind of chasing that for a long time. And I really see some of the innovations that have happened in software development since then as kind of being really returns to that mode. In particular for me, I came of age in an era like just after I got into programming. A few years later, we kind of had the real Cambrian explosion of scripting languages, where suddenly that was a big deal, or what they called scripting languages. And one of the things that made scripting languages so exciting was the fact that they all came with a REPL. They all, if you went into their tutorial, they'd be like, well, first open up the REPL, and then start typing these commands in and see what happens. And this was like, coming from a lot of compiled, waiting for compiles and integration cycles. It was revelatory, and then around the same time, some sort of programming counterculturalists almost, Ward Cunningham and Kent Beck were saying, what if we, turned up the testing cycle to 11 and came up with this concept of test-driven design or test-driven development. And that, again, was a way of sort of fitting these tight feedback loops into even compiled languages like Java and C++. I did some of my first TDD in C++, believe it or not.
Yeah. My most pleasurable experiences, I remember years ago developing, even today, is kind of tight-knit extreme programming teams. I mean, like you mentioned concentric circles of feedback loops. I think it's a great metaphor, because I literally felt that when we were on an XP team with the business analysts there, and it was probably the most flow I've ever felt. I guess, a question I have, and kind of curious to really get your thoughts is, so, I went from, basic to Turbo Basic to Pascal to Java, C++. Like, you went from something that was instant feedback basic and allowed you to do things like play music, write directly to the screen, do graphics, to like Java and C that felt a lot more separated from that. Then later on back to JavaScript and REPL-based languages, where you feel like, okay, a REPL is like it's made for a human. Like when you're not using a REPL, you're writing for a compiler. When you're using a REPL, you feel like you're writing for yourself.
Yes.
I feel like I'm losing that connection again with cloud development, because there's like huge activation energy you have to go through to get stuff up and running on the cloud, to do distributed computing. And so I have a hard time feeling that flow when I'm doing stuff on like, AWS, for example. I'm curious.
Absolutely.
Countered that. How do you grapple with that?
Yeah, it's difficult, isn't it? And I think you're absolutely right, is that we're moving into another phase of, okay, we're sort of increasing the scope again, we're increasing the size of what we work with, and we're introducing new latencies and new delays in our feedback loops. And it's difficult. I think a point that that my partner and co-speaker on this talk in Philly, Jessica Kerr, a point that she likes to make a lot is that one of the ways we kind of bring her back around to that REPL experience is by really leaning into distributed tracing and observability, and really, instrumenting our code so that it is so we have those distributed traces, and then learning how to use tools like Honeycomb, et cetera, to really like dig into that data and kind of ask questions about the recent past.
Yeah. I that was a great talk that she gave on, observability, distributed tracing, that I felt was really good for people that were non-developers to understand, like like she kind of went through how you're telling a story.
Yeah.
My takeaway was like, if you want to feel your code, touch it, smell it, like distributed tracing, observability kind of gives you, your 5 senses back around your code.
Yeah, for sure.
That plus, if you do things in containers, for example, then you've got like the ability to take that complex platform, at least run some semblance of it locally and interrogate it on your computer instead of waiting for a huge build. Hopefully that it's the container itself when you launch quickly if you do it right. So
yeah, I mean, and I do a lot of work in development containers these days. As a matter of fact, I do all of my work in containers these days, because as a consultant, I need to be able to switch between very different environments very quickly. And that does help. I do think, though, that part of coping with this new world is really, it's trying to do as much as we can in production and recognize that that we are not going to reproduce these environments on our local machines as much as we might try. It's one of those things where when you try to get that last 20% of verisimilitude of likeness to the real world, you wind up pouring 80% of effort into it, and you never actually get there. You never get there. There's always something that fails in development, works in production. There's something that fails in production, works in development. And so, one of the things that I like about the approach of using more distributed tracing is just saying, okay, we get it. The only thing like production is production. Let's understand as much as we can about production.
Very fair point. Yep.
So, I guess on that point, how do you approach that initial? So I always find it's that initial hurdle of getting everything set up. Like, so you can start with containers, you can start with like a templated project. So if I'm a new developer, to me, one of the nice things about a tight feedback loop is it really flattens or makes a learning curve a lot less steep. And I think that's like one of the biggest impacts of a feedback loop. You can take something complex and make it a lot easier for people to grasp. Again, I think with cloud development, there are a lot of strategies to, I guess, make that better, but it still seems there's a lot of steps to get to that. I mean, I definitely find having Docker containers helps me a lot. But for many developers, that's a big leap. Like, you have to have a certain level of understanding just to kind of grok Docker containers and Linux and things. So do you like these movements around like dev containers and code spaces? Like, what are your thoughts on that?
Yeah. Actually, will you give me just 1 second? I need to step away for 1 second. I'll be right back.
Yeah.
Okay, I'm back. So I personally, I love dev containers. Like I said, as a consultant, I need to switch, between very different configurations rapidly. And I also, the thing that I love about them, regardless of whether you're in that consultant area space or whether you're just mostly working on one thing at a time, is, I've consulted on some projects where, like, one of the things that I left behind was a dev container, and then and they'll tell me that, like, this is the best thing because, like, the next developer that comes along gets like gets up and running in a day instead of a week.
Yeah, right, exactly.
Yeah, that's huge, and it's kind of documented and repeatable by definition. Yeah. So that's
so it's the way I think of it, it's reproducible development, and we get to it gives us a way of documenting all the little finicky nitpicks about environment setup and everything. It's much more transferable, and it really lends itself to that to the feedback loop. It lends itself to accelerating that particular loop, and it lets us transfer. I really, really like executable documentation. I think that any kind of project documentation that isn't executable in some ways tends to rot really fast. It tends to get out of date because nobody really notices. And having the project setup be entirely executable, when something breaks, you go and fix it, and then you commit that fix, and it lets you kind of, as you build, part of our feedback loop, part of our development loop is building up little tools, building up little scripts and things, and it's like so useful to be able to make those transferable in a way that just works. So
can you loop back on executable documentation for people who aren't that familiar with it?
Yeah. So executable documentation is basically just the idea of, okay, we could write a README, we could like write down what we just learned about this process, or we could try to find a way to encode what we learned in a way that we can run. And there's that takes a lot of forms. A form that I just did the other day with a team that I'm consulting with was, we had to do a lot of research to figure out how to remove permission grants from a particular OAuth 2 provider. and it was not at all clear how to do it. We had to like dig around a lot, and we almost got to the point where we're like, okay, we're going to like document the things we learned with some links to websites in the commit message, and that's going to be it. And then we were like, no, we're going to spend a little bit longer. We're going to write a script for removing these permission grants. And at every level, if something fails, we're going to output something useful from that script that says, have you tried this? And then we put that in our project scripts directory. And, it's, the knowledge will still probably rot at some point because somebody won't run that for a while. But it's just like, just the fact that we know it ran once, like this isn't a README, some stuff that we dumped into a README that probably is missing a step.
It worked.
It's something that we actually used once. And so there's some confidence there that if we tweak it, to match the new reality, if we rebase on reality, as Jess would say,
I like that.
or rebase on the world, then it'll work again. And so there, it gives you this sort of stable foundation.
Awesome.
I wonder, since, you teach quite a number of students in a lot of different courses, have you come across particularly powerful metaphors or analogies to some of this stuff? So, I watch my daughter learn and play piano, and, music in general, or art, sculpting, inherently high feedback is instantaneous visualization and feedback of what you're doing. And to me, that's like kind of the holy grail of, getting programming closer to the feeling of sculpting. To me, that's like you get in that state of flow where you actually feel like you're sculpting your code. It's really hard to achieve that. And when you get it, it's the most fulfilling thing. So I'm curious if there's certain patterns or things maybe outside of the normal computer science discipline that you apply when you're teaching.
Yeah, I love metaphors, and I find that like usually they just sort of come to me in the moment. And whenever anybody asks me for one, I stumble.
I don't have it. Yeah, I know the feeling. I'm like you that way.
Sorry to put you on the spot.
No, it's fine. There are a lot of interesting metaphors that we could talk about and when it comes to feedback loops, and it depends on like what aspect. For programming in general, for a long time, I really kind of glommed onto a gardening metaphor. I think that programming in many ways feels like gardening because you're working with a complex system. It is a system that develops on its own outside of you. It's not, as much as we might like to think otherwise, we don't control all of it. The world keeps moving out from under our feet, and other people are doing other things. And so it's one of those systems that we have an influence on, but we don't have control over. And, we can just do a little bit every day to kind of influence it in the right direction. Lately, I'm starting to think of my gardening metaphor as a little bit limited, though, because it's still a kind of an individualist focus on like, okay, this is my garden and I am making it into, my lovely garden. And really, real software that matters to people isn't like that. It's, I think, more like a farm. And my absolute favorite podcast right now, really the only one that I listen to at the moment, is Dr. Sarah Tabor's podcast, where she talks about farming, where she talks about the history of farming and the science of farming. And I'm not a farmer. I'm only even like the most casual possible of gardeners. But it turns out that, farming influences so much of the world around us, and so many of even like the metaphors that we use. So many of the metaphors, particularly in the world of like Silicon Valley software companies, are based on sort of the homesteading model and the blazing into the wilderness model that we don't really interrogate all the time. And she has some fascinating things to say about how, like, over the whole course of history, individual family farms have actually never worked. They've always, like, working individual family farms have always been an aberration. The farms that have really succeeded in the course of history are more like what we had, like here in the Americas before the Europeans invaded. We had sort of communal farming that had a lot more sustainability because it had fewer points of failure and a lot more diversity in the system. And as I go on, I think, it's large software projects are very similar to that. They are they're large, complex systems where you absolutely have to take into account the the human part of that socio-technical system.
I love that that metaphor, the farming, gardening thing. I think that's really powerful. I'm going to thank you for the podcast recommendation as well.
Yeah, for sure.
That's
so I was wondering. Yeah, go ahead.
Sorry, no, I was reading something yesterday. I forget the name of the island. It's one of the most remotest islands in the world. I think it's technically part of the British territory. There's like a population of 200 people, and they've, maybe a couple times a year, a ship comes to deliver some goods and things like flour, fuel, etc., like cotton for fabric and stuff. And everyone on the island essentially takes turns farming. Doesn't matter what occupation you are. Everyone shares in that. And kind of you mentioning communal farming reminded me of that. This is some of the very limited resources, so far away that they don't have much contact with people. Yet there's this inherent, like, okay, we're all in it together. We got to survive together. We're all going to share the duties. And so they've been surprisingly successful for a couple centuries on their own.
Yeah. It's fascinating to me. Some of this history, like that of indigenous farming, the U.S. and Canada have in their histories have sometimes like deliberately broken up indigenous communal farms because they were outperforming their like homesteader farm, the homesteader farms that were over the next hill so much, so profoundly that it was like, well, this can't stand, and so I think there are some useful lessons there. We without even thinking about it, I think we bring up a lot of these kinds of metaphors in how we think about how we work. In particularly about like just the very sort of individualist model of what a software developer is supposed to be. And this sort of individual hero, this passionate, driven individual hero cowboy. And that's not how sustainable systems are maintained. It's just not.
I think that's pretty fair. And so speaking of that, kind of like bringing it up above, like just the individual coding day to day and around process, are you in this talk, you've gone through like different levels of feedback loops, like from the lines of code to the unit test of the unit to, integration test to, bring the REPLs in, etc. At the higher levels of like just determining process, determining requirements.
Mm-hmm.
You had a really good quote in your talk about the fact that the minute you hit Jira and you make sure that your business people look at Jira, the game is over pretty much. It's like, this is not going to be a good feedback loop. It's going to take a long time.
Yeah, particularly so like, and I have to give Jessica credit for that piece too. She really made that point, which is that if one of your most important feedback loops, of course, is what are you getting from your customers? What are they trying to tell you? And if your feedback loop for what are your customers trying to tell you is enough customers have trouble with a feature that they reported enough times that your customer support people make a ticket about it, and then they bring it up in the next sprint planning, that's a really long, lossy feedback loop.
Yep, sure.
And one of the things that I really like to encourage developers to do, if they haven't already, is go out of their way to make friends with folks on the support team. If you have the opportunity, shadow them or work with them for a few days. Some companies, I really like it when I see companies that, as part of the onboarding, have developers work with their support people for a while, and develop those actual like person-to-person lines of communication, because our job isn't just building better feedback loops for our coding tools. It's not just about, oh, how can I make my VS Code 2% more efficient in process. It's about building these higher level feedback loops, and one of those is establishing conversations with the people in customer support, establishing conversations with the people in sales. is really important. And I think it's something that we so often just assume that the model is going to be sort of developers on this side, salespeople over here with largely divergent values, and there's sort of, basically clashing in, and the field of battle is Jira.
Yes, not mine, his, theirs, whatever. Yeah. Who is it? Yeah, who's working on this?
And I had a coaching client recently who was like, okay, so I'm the person, I'm tapped to develop this whole new feature set that we're currently selling to our existing clients. Like, we're going to have this feature, and so and he was saying that my job is to develop this, and I was like, what's the name of the salesperson who's selling this to your clients? Because either that salesperson becomes your new best friend,
right?
Or they're going to become kind of your enemy.
Yeah. Especially if the communication is sporadic.
Right.
I'm doing what now? This doesn't work anymore. We're changing the way we do X. And I have 10 customers can't upgrade.
Like, sometimes it's important to have that buffer of, like, they need to, for the product manager and your team leads, to kind of have some management buffer space there, so that you don't have somebody breathing down your neck and dictating your every move. But on the flip side, when we're talking about something where, like, you're kind of developing this new feature to suit your existing clients, you need to work closely with the person who represents those clients' needs and who's telling them that, this is what we can do and this is what we can't do. And a lot of times what actually stems from those conversations, I think people assume that it's going to be it's going to be kind of antagonistic, but a lot of times what stems from those is discovering, oh, we actually don't need as much as we thought we did. Like, you'll be like, oh, well, I can give you this spreadsheet, and they're like, oh, that's all I need. That's good enough for now, as long as you can give me something. So those can be really valuable feedback loops.
Yeah.
I think it was Jessica that said that the spreadsheet's like the ultimate business user feedback loop or something along those lines, because they can just quickly iterate and change data and look around at data, experiment with the data they get in their own thinking.
I mean, those conversations can also lead to things like, oh, I should be logging this, or, next time this occurs, I'll have this information ready. Like, I guess you gain empathy for what the customer support person is experiencing, what information they have to report back to the actual user.
Mm-hmm.
Yeah, for sure.
Yeah. And it's also important to have empathy for what your business people are looking at. They have their own tools that they're using to understand the business. And I think one of our jobs is to push back when they say, can you get me a report that will tell me this? And to say no. But what I can do is I can make sure that we feed the information that you need into our existing business intelligence tools, or I can make sure that you can get a CSV anytime you need it, and you can do whatever report you want in Excel. And Excel is like one of the ultimate REPLs. It's wonderful, and empowering the business to get developers out of the critical chain of just business pivots, business intelligence, is another way that we support the feedback loops that we're embedded in.
For sure.
You mentioned Excel, and this is a tangent, but I just wanted to point out a comment that Chris Burster made on the live chat around Jupyter notebooks in Python world, which I completely agree. Because to me, when I started using Jupyter, the first time I was using it was actually not with Python, but it was with Scala, and it was for teaching a large class of students. So I did all the exercises, et cetera, and marked down in Scala in the Jupyter notebook. And then everyone could just check out the notebook with the exercises information, and then along in the class, perform the exercises and then execute their code. And just that whole feedback cycle for development and visualization in general, but for teaching others and having a notebook environment, to me, that was revolutionary in my mind, at least, to be able to teach students.
Yeah, for sure. That was actually, it was a piece that we dropped from the talk that we did just for time, but it was absolutely it's one of my bullet points of this is an example of a great feedback loop, is Jupyter notebooks and things like them.
Yeah, especially if you're good at analyzing data through Python. I was using it to pull in data and generate statistics on it, even from our recruiting, to be able to keep track of how we were doing things. And it was just a beautiful thing to do. You could easily, plot graphs, change the way you're looking at the data, throw it into like a SQL type database and ask questions. Just a nice way of analyzing that, writing a lot of programs, without having to support them later. Because sometimes those questions are one-off questions that you won't need to ask over and over again. So going through the development effort to do that just for one thing that might not happen again.
Yes.
Could be a lot of energy wasted.
I believe that's one of the great lessons of REPLs. The whole idea of this talk was let's say for the sake of argument that a REPL is a pretty much perfect feedback loop for the level that it's at. What can we learn? What can we learn about feedback loops from that? And I think one of the really important pieces is lossiness. It's lossy. It's we have a temporary memory, we have a temporary scroll back buffer, we have a temporary history of commands that we can up arrow through, and we have some state that we build up over the course of that REPL session, variables and whatnot. But at the end of the day, we can always throw it away, and we will throw it away, and we'll start fresh, and that's actually really powerful. Part of being able to arrive at solutions is knowing that we can scribble down, notes along the way that we're not going to have to keep, and having environments where we can do kind of lossy exploration. And one of the points that we like to make is that the REPL in particular is very private, and we don't think about this much as a value in programming. And for me, I've always been a pretty big advocate of pair programming and group programming, but there is value to sometimes having an environment where you can just do stupid stuff. You are a little embarrassed to try.
Haven't done before.
Yeah. And, and just not, look completely incompetent. And, the REPL is like Vegas for that. What you do there stays.
That's true.
And you're not committing this code. You might arrive at some code that you can then transfer into code that you commit, but you're not committing what goes in there. And I think there are all these, it's important to find sort of gradations along this continuum from total lossiness to, kept until the end of time. We talked about Jupyter notebooks. That's sort of a midpoint. It's not as rigid as code that we maintain and refactor for the main application, but it's also not as lossy, not as immediately lossy as a REPL session. It's something that we actually may share with other people, we may transfer to other people, and so it's somewhere in the middle there. And being able to choose along that continuum instead of just saying everything we do is captured forever is really powerful.
There's so many quotes from this podcast today that I'm going to list and attribute you and use just the field of battle is Jira. I just love that. Absolutely. That captures so much in one sentence about what's wrong with how large teams develop products.
Yep.
I think for me, that's one of the largest struggles is when I'm on a small team, it's much easier to practice some of these concepts and things because just by the very nature of being small and less communication overhead, you're getting more feedback. The feedback loop is tighter just by definition. As the teams get larger, and you have multiple personalities and politics and other things, it gets harder and harder for people to align on incentives and goals and kind of do this, turtles all the way sort of approach. It's fulfilling when you can do it. It just gets challenging.
Yeah.
And that's why you mentioned in that talk about REPL nature, like Buddha nature,
exactly.
Thinking about letting as many layers of the business gain access to things in a way that they can query and interrogate and ask questions of it, get answers, have a conversation, as you were mentioning, with your code.
Ultimately, I think it's useful to think of any of these feedback loops as conversations.
Yeah.
And I think one of the reasons it's useful to think of them that way is because it's useful to think about, okay, what is the pace of this particular conversation? One thing that I think is important to note when talking about feedback loops is that I think it's popular in software circles to say, okay, here's a thing that we've decided is good. So now we have to maximize it. Now we have to accelerate it. Now we have to turn the dial up as far as it can go. And I think there's a naive view of feedback loops where we say, okay, feedback loops are good, therefore we must make them as fast as possible. And that's not actually what I'm saying here. And I think that can be detrimental. What we want to do is we want to identify the natural pace of the loop that we're thinking about right now, the loop that we're working in and focusing on, the natural kind of conversational pace, which is like, how fast do we form the next question? So, if you have to, punch your program on a stack of cards and you have to wait 2 weeks until you get to run it again, you're probably going to come up with 6 dozen different questions about, what you could try next in the space of the time that you get to try one question. And that's clearly too slow of a rate. But speaking of metaphors, Jess has this great metaphor of the shower adjustment cycle at an unfamiliar hotel, where you're trying to get the shower temperature right, and so you turn it a little, it's still too cold. You turn it a little, it's still too cold. You turn it a little, it's still too cold. Suddenly, it's too hot, right? Because you're not actually working at the conversational pace of that particular feedback loop. Like, you haven't given it time to actually produce feedback in all those little adjustments.
Oh, that's hilarious.
My father used to have boats, and he would have a big old, 27-foot engine boat. And when you take those things out and you said, "Here, son, try to drive." Okay, I'm going to go left.
That's funny.
Not going left. Not going. So we're going left. It's the same thing. It's like this delay of like 8 seconds until you even know that you've done the correction you need to do.
If you're waiting for your nerve endings to tell you it's too late by that.
Yeah.
Yep.
I had my personal metaphor for this, which I'll bring up because you brought up the boat one, is like ages ago in another life, I was taking flight lessons.
Cool.
And, one day I'm up with my instructor in the back seat because it was a sailplane. And, so the instructor's back there and he can feel everything that I'm doing through his controls because they're all linked. And I was feeling like I was having a really super good day because I was just like on top of things. Like, I was feeling every little like movement of the plane, every little wind gust, and I was just adjusting and adjusting and adjusting, and finally I hear from the back, settle down. Because he's feeling like all these little micro adjustments that I'm making, and none of them really mattered. Like, none of them actually mattered to the flying of the aircraft. I was just sort of convincing myself that all of these little instantaneous micro adjustments were important, and they weren't. And there's a lot of places where that applies in software. One of the ones that always comes to mind for me is A/B testing. It's which is one of those things that can be super useful, but it can also be a thing where you get just a whole lot. You can ask a whole lot of questions and get a whole lot of hard data answers really fast that mean absolutely nothing for your business. But boy, they're data.
Yep. Yeah.
That's an interesting segue into curious to hear more your thoughts on continuous deployment, feature flags, and A/B testing kind of sort of made me think about that, how you run those experiments in a safe way, but you can gather a lot of useful information doing that.
Yeah, I mean, the short answer is I'm in favor. Like, this is one of the ways that we bring our larger development cycles into the sort of appropriate pacing, we'll call it, not fast as possible, but appropriate pacing to the kinds of decisions that we're making and the questions that we're asking. Is we get our continuous integration, we get our sorted out, we get our continuous deployment sorted out, and we give ourselves the ability to get code into production without breaking things, and and gradually turn it on for people. I think that's essential to staying in a healthy feedback loop at that level.
Okay, cool. Do you have any other questions on your end, Sujan?
I mean, this is.
I don't go on forever.
It's something you can talk about forever because, again, it's so fundamental that everything we do, right? It's beyond just programming. And again, I try to, as a parent, right? You try to I think feedback loops with your child, for example, are really important. Just when they're learning, when you're seeing how they react to things, and it's interesting, right? They very quickly react to what you say, so you're getting instant feedback on like, oh, am I performing well as a parent or not, or am I saying something that they fear or they got hurt by or they're really happy by? So I think it's a interesting playground and experiment. At the same time, it has serious repercussions because you're like affecting this other person, this creature. But again, I'm just at a loss as to why more schools, universities, and don't teach this way. And I think it's a huge gap. And it's like, okay, colleges in the United States is super, super expensive, but there's a lot of times it's not the optimal way. I would say probably most of the times it's not the optimal way to learn certain subjects. And I found myself, certain online courses and things where the professor is teaching because they purely love to teach. It's not something they have to do so they can get research dollars in or grant money in. I learned much more effectively that way because the teacher's passionate about it. They approach it very differently. They're not beholden to following a certain structure that the university forces them to follow. And I think there's so much improvement that could be done to unleash this kind of stuff on the masses if people just change how they teach.
Yeah, for sure. I mean, my primary business is making videos and courses for programmers, towards the end of, towards the goal of helping them kind of level up their practice. And when I talk to people about like how to craft training material, I think that one of the first things that I always talk about is contextualize. I think that's the thing that the vast majority of probably in any field, but certainly in software development, I think is the vast majority of it is lacking is just contextualization. It's just not just here is what you can do, not just here is how you can do, but first let's step back, contextualize the problem. Where is this appropriate? Where does this matter? And why?
That's a really good point. Yeah, that's a really good point. I feel that way a lot with things like math math can be very well applied for solving problems, but everyone teaches it so academically and dry. And I know one of my daughters has really struggled through Algebra 2. And when I'm looking at the guides, I'm like, they really don't give you an idea why you need to know these things at all. It's just thing, quiz,
Yeah.
Maybe you could do this to solve this kind of problem. Let's break it down. Let's see why this approach would work. Maybe this other approach would work better.
Mm-hmm.
It doesn't get taught that way. Early on with programming, back when I was a kid, they had, I'm an old now, but the kid, it was like people came up with Logo, because Logo was a REPL that drew things with a turtle.
Yes.
Yes. And it was like a very early, educational REPL, so to speak. And I always liked that. I always liked the fact that you could experiment with the language just by asking them questions as a kid, because you have a very limited language to work with, and you get it to do stuff. And I know they've tried doing that with blocks and other things since. And I think some of the more progressive teachers of electronics or such will use those kinds of features. But it'd just be nice to see this in more places.
My introduction to programming, believe it or not, was my 6th grade social studies teacher, of all people. We had a bunch of TRS-80s in the classroom, and he would program in BASIC quizzes and ways for us to learn the concepts and stuff he was teaching about, like Egypt and other countries at the time.
Oh, wow.
And he would do he'd have these ASCII art animations. They were like these little mini role playing. You answer a question and you get to the next thing. And like, okay. And he used programming, and that he would kind of show us the code to teach these concepts. So it wasn't dry. It wasn't like, hey, I'm learning code just to print out a bunch of letters or numbers in a for loop. It's like, okay, someone coded something to actually teach something completely different that had nothing to do with coding. And that connection was so powerful. It's like, I always find that pretty novel. Usually most people, I think their introduction to programming may be like video games or an elder sibling, or, they're not your social studies teacher.
No, that's very cool that you had that experience.
Yes. Yeah. And this kind of brings it almost full circle to something we talked about at the beginning of this conversation, which is some of these early mainframe systems that enabled a lot of people to learn how to code and to experience kind of an early REPL. They were not pitched at the software engineering community. They existed as part of educational systems. They were created for college students and then high school students, things like the Dartmouth time sharing system and the Plato system in Illinois, which was incredibly successful. They were built to enable kids to learn. And as a side effect, they also were incredibly rich interactive programming environments. And they were also pitched to enable people to solve real problems. The DTSS, which I talked about in that talk, the Dartmouth time sharing system, where so many people learned BASIC, and which BASIC was created for. Something like 80% of the student body was using it, and that it wasn't like the computer science student body. And this is like 1972. Most of the student body was using it to like do their homework and stuff like that. Not to cheat on their homework, but like as part of, exactly what you're talking about. Like here's a problem that has to do with social studies. Here's, an example that comes up is like population growth calculations. I have this wonderful little pamphlet that was written back then to introduce the basic programming language. And unlike programming guides that you see today, where it's like, here's how you can add integers, it's like, let's talk about population growth. How might we do some calculations about population growth, which is this big issue that people are talking about right now. And it contextualizes it, like immediately from the first couple of pages, it contextualizes, here's why we might do this stuff. From a very deliberate point of view of, we want to create digital citizens. We want to create people, citizens who are empowered to solve to participate in solving the problems of the day. And I think it would be nice to see more of that.
For sure.
Very well said.
So as kind of a wrap up here, so Graceful.Dev is your website. That's the main way to find you. You've got
you can also find me at avdi.codes. That's kind of more of my like personal all the consulting and stuff that I do, but my biggest output is Graceful.Dev.
Are you going to any other conferences coming up?
I don't have any scheduled right now.
Okay, well, it was an honor to have you at ours. So, and I understand you and Jessica drove back and forth. Is that true, or is it just the way back?
We drove back together. Yeah.
Okay.
Yeah, I had reason to be in Pennsylvania already, and I had driven there. So yeah, we drove back across country. Yeah,
she is really, really smart and fun to talk to too. So that must have been a great ride.
Yes. So, yeah, we actually I'm trying to remember where we posted it. We had one conversation that we recorded on the way.
Oh, cool.
And I think it was I think we posted the recording on our Patreon.
I figured you would do that. I figured you would have a recording of that. Because the last two talks you've had with us were both of you talking together, and they were both fantastic. All right, Avdi Grimm, it's been so nice to talk to you today on the podcast. We really appreciate you taking the time.
Thank you so much.
And your talk is wonderful, and keep doing great stuff in the community. We love it.
Thank you so much. It's been great.
All right, take care.
You too.